welcome to the second installment of Magnets and Electromagnets. Examine the diagram of the interior of a doorbell. Explain how it works. Okay, so here it is, the schematic of the doorbell. So you've got your power source, you've got one terminal going towards a wire, you've got your switch, another wire going around some coils, another set of coils, you've got your wire ending here, there is a hammer connected here, you've got a make or break contact which is connected through another wire back to the power source. So at the present time, of course you've got the bell as well. At the present time, this switch, you see how there's a gap here? The circuit is not complete, so no electric flow is going to happen. So how do you complete the circuit? By having this piece come down and make contact. And if you push the switch, as you do with the doorbell, this will make contact and you close the circuit. So that's the first step in explaining how this works. So number one, when switch closes, circuit is complete and current flows. Okay, so that's the first part. So now we've got current. So we've got some energy coming from the battery. It goes through this loop and all of a sudden it starts going through these coils. Now remember, based on the right-hand rule, based on video 169, when you have current going through a coil, right, your fingers are now representing on your right hand. The fingers of your right hand represent the direction of the current, and you have a magnetic field, right, based on the direction of your right thumb. So now there's an electric field produced here, sorry, magnetic field produced here, and you've got the current then going through another set of coils, another magnetic field produced here. The current finally finishes off, goes through the rest of the wire. Here is your hammer, and you have a make or break contact point. Now, when the electrons are flowing through, remember, there's only two ways magnets can occur. It can occur naturally through some materials. It's rare for materials to be naturally magnetized, but there are some materials like lodestone. But a more common way that we do it now is by producing an electromagnet, and this is the electromagnet. So the current through the coil produces a magnetic field, and because there's a magnetic field now, this hammer, now it's made of a special type of metal that can be magnetized. This is then attracted upwards, right? It's attracted upwards due to the magnetic field. When it goes up, the hammer hits the bell, okay? And then you break your contact, the current shuts off, and it's done. So that's my second step here. The current through the coils. So current through coils creates electromagnetic field. Which means the metal rod is attracted upward. And then when the metal rod is attracted up, the hammer hits the bell. And that's it. That's how the alarm works. This is an older style alarm, but the same basic idea works nowadays. Okay guys, that's it for this video. I hope you enjoyed it. If you have any questions, be sure to leave them in the comment section below. Otherwise, I will see you tomorrow at 12 noon for video 171, Magnets and Electromagnets 3.